Alright, so let's remove the board. And again, what we're trying to do here is preserve the soldering pads because those still need to be used. Okay, that's free. This one's got a little more solder on it. And the reason why these pads need to be left intact is in order to use this circuit, that was close, you need to re-solder these, and I think I'm free. You need to bridge these contacts to complete the circuit. That's that. And let's there it is. Okay, so that's free now. And now we can take a closer look at the solvent. So we're going to try and dissolve that rather than brute force it out. Alright, so since these holes are a little less accessible on the stripe style flywheel cages, the easiest way that I found to pop the flywheels off, you don't want to use metal because anything that's harder than the plastic is going to dent it. So we're just going to push that in here, push that in there, and that'll allow us to pop it off like that. And we can see no damage. So use wood. I think these chopsticks are actually made out of bamboo, but anything softer than plastic is what you want to use for that. Alright, so now when we get to removing the motors from the flywheel cage half, usually all you end up doing is pushing it. Like push the rotor shaft and the motor pops right out. But as you can see, we have this glue, and if you push, what's going to happen is the plastic end bell is going to pop off. The two little metal tabs here and here are what holds that in place, and those are easily bent by hand. So if I just push down like this on a hard surface, what's going to happen is the caps are going to pop off and the rotors are going to pop off along with it. So then what you're going to end up with is not the shafts, but the ends of the motors, and you're going to pop something in there and have to tap on them, and you're going to have to tap repeatedly and pretty hard. And what you can end up doing is damaging the alignment hole here. Alright? Worst case scenario, you can start chipping away at plastic, and what that's going to do is that's going to cause rattling when you mount your new motors. Now the easier way I found of doing this is to use your X-Acto knife to cut, and I did this after using a little bit of goo off, which may have softened the solvent a little bit, but I believe it can probably be done without using the goo off. So you just cut all along here, and what that's going to do is it's going to loosen enough of the glue so that you can remove the motors in the normal way. Just put the shaft down on something hard, slowly push down. If you see the end caps moving, these little tabs here, if those start giving away, then you need to cut more of the solvent that's holding the motor in place. So if you pop that out, you can see where the contact points are on the solvent. It doesn't cover the entire motor, but you do need to cut all the way down, because the solvent is here, here, and here, but not on the side of the tabs. So once we pop that out, all we have in here is just the glue residue with no damage to the cage. Alright, so replacing the motors. You've already used these FK180 SHs, but the problem with that is because they do not fit flush inside the shell, you need to cut holes out. We want to avoid that this time, so we're going to have to go with these lower torque motors, and these are FF130 3733s, and at 7.4 voltage we should be looking at RPM speeds of anywhere from 40 to 50,000 RPM. So it's almost going to sound like a dental drill at full rev. And if we do a little sizing, we can see that we might have to shave the tabs in here a little bit, so we can either Dremel that out or chop it out with a hobby knife. It might actually fit. Yeah. So we're going to take these tabs and Dremel those out for a nice tight fit. Alright, so we have bridged the circuit that would normally flow between the flywheel motors. Rotates this way. And you're going to see that there's no longer anything holding this in place, because it was actually the wire tension from the solder joints that kept this in place. There's no screw. So what you can do is take a washer or one of those screws that has the washer built into it to hold this board in place, using this mounting hole right here. But what we've done with the resistor board itself is we have this jumper wire going from here to here that used to flow through the motors, here to here, that used to flow through that motor. And the reason why we don't do that is we're going to get a direct line to the motors direct from the battery. So the circuit is no longer flowing through the sound card, through the resistor board, into the motors. We got a direct line, and that is going to give us that high amperage that we want directly feeding off the battery. If we do a little circuit check to see that the jumper still works, you can see now that we have no flywheels actually mounted. They're here, but they're not attached to anything. The circuit now works independently. Alright, so here is the optimal way that I found of mounting the high amperage microswitch here in the stock housing. Unfortunately, we are going to have to lose the rev lock, which means it will actually be possible to pull the trigger with this configuration and potentially jam darts in the flywheels when they're not being activated. But there are always going to be trade-offs when you're doing aftermarket modifications. So if you take a look here, you can see that this has all been cut down. I wanted to keep that peg, but without the support, that peg is simply too flimsy. But because this piece here is intact and this piece here is intact, and as you can see, you have one of two options. You can either cut off the normally closed peg, or you can cut a slit here to allow it to fit in. And you need to make sure that it cuts very low, and you can see that it mounts almost flush. Alright. So this wire is going to run, these two positives are going to run to the battery and the flywheels respectively. And for now we are going to be ditching the idea of having the motor braking. Normally what you would do with this one here, normally closed, is going to be a negative wire, and that is going to go to either the negative terminal of the battery or the negative terminal on your motors. Alright, so going to the activation switch for the flywheels, you have to cut this part off. You can see that normally the profile would travel into this empty space here, so that has to be cut off, and then this recess has to be cut and filed down. You want to make sure that it's nice and smooth when it enters the box profile, which we left intact to hold the switch in place. You can use a slightly heavier tension spring here to keep everything with a good amount of feedback, so it's a nice clean contact. For the UV LED piece, this tiny amount of tab here, if you cut that off right there, that will allow for tension relieval. Because if you're using the 16 gauge heavier wiring, it won't fit into that gap. It's meant for this this thinner gauge wiring, which like this here, which is still left intact using stock, because all this is doing is activating the sounds. You don't need the heavier gauge wiring for that. The heavy gauge wiring is only necessary for having a direct clean line from the upgraded battery to the flywheels to the activator. What you can't see here is there's a tiny amount of shell support. You also want to cut a small little recess for the heavier gauge wire as well. And the main reason for doing that is, again, it's relief, so you don't pinch the wires and potentially cut the insulation. Continuing on with our function check, we can see that direct line, positive, positive to our normally closed and COM into the flywheels, negatives feed into our XT60 connector. So a quick rundown on how you're going to wire both of these circuits, the one for the sound card and for the lights, into the high amperage, high output rev circuit. So it's pretty simple. These here are your positive and negative leads that are going to feed into the battery connector. So you're going to solder all four of these wires into this XT60 connector, and that is what is going to enable both while maintaining the pew-pew functionality. So as you can see, that's all running off of the same 8.4 volt battery, which is currently at 7.6. Holds up fine under full charge. I've already done this before with another one. And you can see that both of the circuits are, again, feeding off the same battery. We are going to leave the thermistor board here. We did cut the blue lead that usually goes to the normally open of the microswitch, the stock switch. We no longer need that one, so we have power from the battery going direct through the thermistor board to the sound cord, and that's going to provide a little bit of additional resistance and hopefully prevent that from damaging the capacitors. On the resistor board, side note, and this is an important one, you can't see them now, but this spot here and here is those were the inductors. So they look like capacitors. They're kind of sea green. Those need to be cut off because when you're running the amperage from the LiPo battery through here, those will burn out. Now if you cut those out completely, here and here, the circuit will still remain functional. Alright, so final function check before we seal everything up. We now have the negative lead coming off the sound card to the negative lead or negative terminal of the XT60 connector. The positive terminal is coming from the thermistor board that used to go directly to the battery tray. We're still keeping that intact, and that is going to go from the thermistor board to the sound card, and then from the sound card we have power going to the resistor board, and this is providing resistance for the UV LEDs for the GlowStrike function. If you notice here we have the positive lead. This used to go to the switch over here. This is going to go to the flywheel. So the flywheel circuit goes to the switch, and that will activate the UV LED when the switch is pulled. And of course, the sound and light functions are still intact. As for the battery tray itself, this piece can be reused, making sure that when you cut, you leave enough of this tab to fit in this part of the rail here. And that will give you the mounting hole to screw in the battery cover. And that is now solvent welded onto the inside of the frame, like so. Recess here is for the battery. That tab goes in like that. This would go like normal. And there you go, sealed up.